Before I was working at Bristol, I studied in Bath, and then I started working for what are called large-scale research facilities. So these are things like diamond light source. So I'm not sure if people know what this is. This is a big donut. This is not GCHQ. It looks like GCHQ, but it's not. It's in the Oxfordshire countryside, and it's a synchrotron radiation source. So people bring their samples. They can be proteins, they can be whole cells, they can be pieces of metal, they can be airplane wings. And they put them on the synchrotron beam, and we fire x-rays at them, and we get data out. And my job when I worked at Diamond was to help people analyze that data. The thing is, Diamond and the place I worked afterwards, which was called the European Spallation Source, which does a very similar thing to Diamond, but instead of x-rays, they fire neutrons at samples. So they can fire neutrons at biological samples, but they can also fire neutrons at, I think someone put a car engine one time into the beam. Now, these facilities are really expensive to run. These facilities are kind of funded similar to scales to CERN in the Large Hadron Collider. So there's a lot of money going into these. There's a lot of people effort. And so we want to make sure that the data that are coming out are the best data they can be, which actually led me to one of your other sins, which I saw a lot when I worked here, of people coming being like that, I've brought this sample and I'm going to look at this thing. And I'd be like, well, the technique can't actually do that. So you really shouldn't have this beam time. So we want to make the most of the beam time that people are getting by getting the best analysis possible. And then I'm also interested in trying to expand the concept. So these facilities, because they're government funded, are very interested in fair data. So they try and make sure all the data is shared following fair guidelines. Your decision on whether or not they're successful in that, I leave open to interpretation. But I think it should actually apply beyond the data. It should also include the analysis. We should be sharing our analysis processes in a more open way such that other people can use them. Because the amount of times I've seen people write the same scripts in different research groups drives me crazy. I've just realized I've introduced fair. Does everyone know what I mean when I say fair? Right, I knew that was going to happen. So fair is findable, accessible, interoperable, and reproducible, or reusable, which is some basically nice buzzwords to talk about how we should try and share our data. We should make it so that people can find it if they're interested. We should make it so that they can access the data once they do find it. It should be interoperable, so it should be in formats that people can understand, hopefully not proprietary. And it should be reusable, so it should be stored with information that anyone can come and reuse the data and understand what they're looking at. Now, that's being applied to data, a lot of these facilities, but I argue that analysis is also a part of that data journey. And so this is why I kind of got into reproducibility when I was working at these facilities and during my PhD before that. And so I'm going to come back to the point that I am a computational scientist. So what that actually means in practice, so I'm a computational chemist or a computational physicist. And what it means is I run simulations of atoms and molecules, and they buzz about and bounce off each other and wiggle and jiggle. And I try and run those simulations so that we can better understand the experiments that we do. And then when those simulations are running, or when my colleagues are making measurements, I tap away at my computer, I write computer code. In my old life, I was a computer programmer. And I try and analyze these simulations or analyze these experiments in the best possible way. Now, the reason I'm telling you this is because it's time for my dirty little secret, which is that I worry that I might not work in the same way as you guys. And it might be the case that at the end of this talk, you'll go, well, I don't code, so this is useless to me. And so I want to give this up front that I am not very fun at parties. I like to code. I've been a programmer for a long time. When I write papers, well, let's phrase this differently. I hate Microsoft Word with a passion. I write my publications and anything I can using LaTeX, which, are people familiar with LaTeX? There's a good amount of nods. It's like Word, but it's more confusing. And I live my life on the command line, which is to say that I really don't like using the file browser. I would much rather go old-fashioned like I'm in the Matrix. Now, this means that the way I work is quite specific, and the tools that I'm going to talk about and the methods I'm going to talk about are specific to that. But one of the things that I'm really interested in is how we can expand it to communities that are more fun at parties, let's say. One of the other things which I hope is similar between me and you is that I can describe the analysis I do on my data as a workflow. I can outline, I do this, 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 and this. I can create a flow chart essentially. And that allows me to use these tools to try and create reproducible analysis, to try and fill that gap where the results that are proposed in papers aren't really interpretable because I don't know what the people have done in the papers. And that's what I'm trying to fill. So what I'm going to do is I'm going to give you a quick journey through my reproducibility life. I realized when I was doing this that the talk was going to be far too long if I give you the full journey, and it'd probably end up quite boring. So I'm going to give you a short journey, and then if I've got time, I'm going to try and do a demonstration of the way that I propose, the way that I do reproducible computational research or reproducible analysis at the moment. And then I'm going to give you a chance at the end to, in the questions, point out why it's a bad idea. So when I was doing my PhD, I got keen on reproducibility. I think it was because I was bored and I wanted an excuse to do more coding. But what I was looking at these, I feel like it's a good life sciences example. Lipids. I was interested in looking at lipids at the air-water interface. And so one of my mates had been looking at this phosphoglycerol lipid at the air-water interface, and he'd also looked at it at the air-deep eutectic solvent interface. Deep eutectic solvent doesn't really matter what it is. It's kind of like an ionic liquid, but a wee bit different. And he was interested in trying to see what changed when he looked at it in these experiments that we conducted at Diamond. And he wasn't very good at doing the data analysis, and he asked me to help him out because I was able to code it all up. And I managed to actually, using some quite advanced software approaches, I was able to get him a really nice result, which was that the deep eutectic solvent kind of caused this slight unfolding of the phosphoglycerol head group due to interactions, because the deep eutectic solvent has charge and the phosphoglycerol has charge. And it was a really nice paper that wouldn't have been possible without trying to bring in this computation. But while I was doing the fun computer stuff, I was like, oh, I'm going to make this fully reproducible. Now, when I say fully reproducible, what I mean is someone can go to this GitHub repository, they can download the data, as in the data we collected at Diamond, so the experimental data, and then they can run a couple of commands, and we will do all the analysis to get the results that were in the paper. And potentially, we'll also write the paper in the reproducible workflow. Now, when I say write the paper, that means take the LaTeX file and put in any numbers that are missing that have been generated as part of the analysis. And now, this was 2019. I managed to do it. So I managed to do it where it was necessary. So it wasn't easy. It was a lot of faff. I probably spent far too long on it when I was meant to be writing my thesis. But I managed to get it. If you go to the Git repository, you clone the GitHub repository. You then download all of the data from the Bath University archive, which is similar to the Bristol RDSF. You then run these 6 commands, and then a day later, you will have the paper that you've already got a copy of. But one of the nice things about this is if I, in 10 years' time, go, oh man, there was a mistake in that analysis, I can then redo it all really, really quickly. But the way that I achieved this involved what's called a makefile. And so this is a snippet from the makefile from this. So who's familiar with makefiles? Okay, good amount of head shaking, that's what I like. So a makefile is used very common in code to explain how to compile software to your computer. So it's meant to be a simplified way of building one of these workflows. It's not very simple. Makefiles, what's actually happened is makefiles, the purpose of a makefile is to make making software easier, but makefiles have become so hard to make that there's now software to make makefiles. So I wrote this all from scratch, and now looking at it now, it gives me nightmares to think about, because there's so much time. There's about 200 lines of code just in this thing that's just to describe a workflow to do a very small amount of analysis. So it wasn't really elegant, but it was a kind of step hopefully in the right direction, and someone could potentially go and download that, redo all my analysis, and just check that I'm not talking rubbish. I'm conscious that there's a camera, or else that would have been a different word. So what I did at the time was, this was pre-COVID, and the University of Sheffield hosted a hackathon-style event. And what they wanted to do at that hackathon event was assess the reproducibility of some papers that were claiming to be reproducible. And you could go on this website. It was part of their reproducibility, like as in a cup of tea, and you would have one of those events. You went on this website and you said, I think my paper is reproducible, assess it. And then they had the event and you got 2 pieces of feedback. So you got 2 people tried to reproduce your work and they made comments on how reproducible it was and scored it. Now, unfortunately, because I've changed jobs like 3 times since this happened, I've lost the original email. So these are paraphrases from my feedback. One person said that it worked great and I followed the README instructions and was able to generate the paper. So it was dead easy. They just did the 6 commands I just showed you. They downloaded the data. Fantastic. The second, let's call them reviewer, reviewer 2, said, couldn't get it to work, probably because I've never installed Python. Which I kind of felt like I was falling at the first hurdle there. Like all my analysis is in Python. You need to at least be able to install it there, which is one of the things that I'm interested in, is how we can make this more open and how we can make this more accessible to those that aren't, or that are fun at parties, let's say. And then to cut the long story short, because I would like to show you the demo, I kind of continued down this path. So there's 3 more GitHub repositories there. There are 3 more examples of completely reproducible work. And I kind of improved on my approaches. Instead of using make, which is this awful thing, I started using a thing called snake-make, which is a wee bit nicer to use. Instead of storing data on the university data repository, and therefore I couldn't download it very easily because Bath University wouldn't provide you just a link that you could put in a script. I started using Zenodo. Zenodo we're familiar with. Okay, cool. I started using Zenodo instead, and these kind of small improvements were going along. So we ended up in the situation where that final one, the model select, was a paper where it was quite an advanced workflow. And I was quite pleased with it, and I was like, right, forever, this is how I'm going to do my publications. I've settled on something nice. And then the thing that happens with everything is you find out that someone's actually already done it much, much better than you. And I found out about this maybe 2 years ago now, this project called Show-your-work. I actually saw it on a guy I knew from some software tweeted about it, and I saw the tweet and I was like, oh, this looks really cool. And what this actually does is this combines a whole bunch of different aspects of what I was trying to do, but in a coherent, supported package, and also adds some additional functionality. It's trying to make these reproducible publications a thing. Now, there's some things on this list that I'm gonna, snake-make, better version of make. Zenodo, we're all happy with. Considering the head shaking, the head nodding when we saw LaTeX, how do people feel about Overleaf? Overleaf, it's just a nice way to use LaTeX. It's the way you get Microsoft Word users to start using LaTeX. And then GitHub Actions. So GitHub is a place that we store our code. A GitHub action is basically when I make any changes to my code on GitHub, a GitHub action can run. It spins up a computer somewhere in the California desert probably, and it does some work. It checks something, it runs, for example, tests on codes, or in my case, it produces the publication. It produces the PDF of the publication. So Showyourwork brings all these things together. It's explicitly being developed by people to produce reproducible publications. The majority of the work so far has been in the astronomy community. So it's actually from a research institute in New York City. And it's under active development, and I kind of ended up getting involved, partly because the guy that was developing it got a job at, I think like Uber or Lyft or one of these taxi service companies, because it was like machine learning. And then the next guy who was running it had a kid, and then got a job at Google DeepMind. So now it's ended up, I think I might be in charge, which is terrifying. But it's under active development, so there is actually, if people have changes, if people want to do things about it, and in my case, if I want to try and apply for money to people to do stuff on it, then there is actually a future for this. There's also a website that you can check out, it's show-your.work. And so I have 3 minutes or so that I'm going to try and do a demo in. So we're going to see if this works. So this is my paper, right? This is Overleaf for those that aren't familiar. This is my LaTeX. And then on this side is the PDF of my paper. Now you'll notice that my figure isn't actually here. I've not made the figure yet, let's say. I've just started writing my text. I've wrote a bunch of lorem ipsum. And if I now go to my code, so here what I've got is my folder associated with my research that I'm doing, my awesome paper. And I've got some files in that I think are interesting. One is I've got a show-your-work.yaml. So .yaml is just a file format that we can have a read of. It's got some data sets in it, and specifically this data set has a Zenodo DOI set to it. And actually I can go and have a look on Zenodo because I've got this data here. So this is my Zenodo deposit for this data, which I've called my latest greatest data. And so I actually tell Showyourwork, this is where my data is, and when you download it, this is where I'd like you to put it. You also then apply some dependencies. So I want to, I have a plot that I'm going to create, and that plot depends, the ability to create that plot depends on the data being present. So this starts to build up that hierarchy, that workflow that I want to use. My plot is quite a simple one. Basically what I'm doing is I've got some data, I fit a straight line to it using weighted least squares, and then I plot the data, I write it as a PDF. This is just straightforward Python. And what I can do is I can then go to my, I can then go to my command line, and I can say show your work build. So you see that I'm doing this down here at the bottom, and it's going away. What it's going to do is it's going to download and install some Python packages. These Python packages I've actually defined in my environment YAML, and I've defined them with version numbers, because one of the things I noticed in my past life was when version numbers changed on software, sometimes the results would change. Very small amounts, but sometimes they would, and it was quite worrying. What it's going to do is it's going to download and install those packages, and then it's going to download the data, because that's the first thing it has to do. It knows it can't do anything until it's downloaded the data. Then it's going to, there we go. So, well, first of all, it's going to check the paper. Then it's going to download the data. Then it's going to run the Python script, and then hopefully produce my paper. If this works, I always worry about doing live demonstrations, so we're going to find out. Oh no, it's going to take longer than my 3 minutes left, which means I should maybe, while this is running, what I'll do is I'll show you my final slide, which is my call to action slide. So I'm letting that run, I'll come back and I'll show you at the end, which is basically, I think this is interesting. I think it's interesting potentially at the moment, unfortunately only for people like me. And I would like to hear about, if you're interested, do you want to try and use it? And we can try and do something cool with it. Or if that sounds awful, because you hate everything I've just told you about, I would like to hear about what I'm doing wrong, how we can improve it, how Showyourwork can improve to be able to help you do your research. Because at the moment it's popular in the astronomy community. There's a couple of material science papers, which are all mine, and that's it. And I would like to expand this sort of thinking to how we do analysis. So that's the call to action. My email address is there. My name has many spellings, but I think there's only one Andrew McCluskey at Bristol, so if you just Google me. I'm just going to see if this is run now. It has, fantastic. So you can see here what's happened. See this bunch of hash symbols down there, or a bunch of, hash symbols, hashtags, as the students tell me they're called. That's it downloading my latest, greatest data from Zenodo. It then runs this plot that I showed you, or runs this Python script I showed you a second ago. It compiles the PDF, and then it pushes everything up to Overleaf for me. So if I go to Overleaf now, I've now got my plot in the figures directory, and if I recompile, hopefully what will happen is that the figure will appear. Now, that also means that if I'm working with a colleague and they look at that figure and they go, oh, I hate blue, I want a red line. All they have to do is clone my Git repository, go into the plotting thing, change this B to an R, and they can then run the build script again. It knows that it's already got all the dependencies and it's got the data. So all it does this time, oh wait, hang on, sorry, I need to do this one thing. So I need to tell the Git repository that I've changed the color to red so that I'm documenting the changes I'm making. So when my colleague goes and messes with everything, I know exactly what they've done wrong. And then realize it doesn't have to change anything in terms of the data or anything. It could just reproduce the plot again and then share everything up to Zenodo, to Overleaf. And if I recompile, hopefully the line is now red. Yeah, it is. I'm colorblind, so hopefully that's red. The final thing I want to say, and I'm aware I'm over time, is that this all links up with GitHub. So if I then push those commits, there's a GitHub action that goes away and makes the paper. So you can see I made a change earlier this morning when I was testing this, and what it does is it produces a bunch of outputs, but what the most important output for me is, if I go to here, I can go to main-pdf, and I hopefully have the paper here. And what that means is that this is all being tested on someone else's computer as well as my computer. It's not the case where it's only going to run on my computer only. This is all running essentially in a Docker container, which means everything is hopefully actually reproducible. So I'm really sorry I went over time. That's really crappy of me. But thank you very much for listening.